So Pyth is an on-chain oracle for real-world financial and crypto market data. And at Pyth, I work mostly on the reliability of the on-chain program and also on the supporting software that sits outside of the blockchain, right? So I said that Pyth is an oracle. For those who are not familiar with the term, as you know, so Solana developers, you know that when you write in a blockchain application, you can only access data that also lives within the blockchain, right? And there's limited utility to what you can do without reaching out to the outside world for data. So the Oracle is this piece of technology that brings data from the outside into the blockchain. So it kind of like works as a bridge. So blockchain programs can do interesting things, right? So some examples of the kind of data that an Oracle might provide are, say, the weather conditions for a certain location, or the current time, or latest price for a company stock, or say like Apple or Netflix. So these are some of the things that a blockchain program would need to reach out to the outside world in order to get the data. And I said that Pyth is an oracle for financial and crypto market data. So the kind of data that Pyth provides is that last example that I gave. So, latest prices for stocks, for foreign exchange, and for cryptocurrencies. So Pyth is not the only oracle out there. There are different and multiple oracle implementations that provide different kinds of data. But I want to talk a little bit about what's special about Pyth and what makes it different than other oracles, right? So the answer has two parts. And the first part is that Pyth works with first-party data. So what does that mean? It means that the data that Pyth gets and publishes in blockchain comes directly from the sources that produce that data. So let's say we're talking about cryptocurrency prices. One way to do it would be writing some kind of like scraper that goes to like coinmarketcap.com or like CoinGecko and gets the price from that and puts it into the blockchain. So that would be considered third-party data because you're getting it from someone else that got it from the actual source, right? So Pyth partners with the organizations and financial institutions that actually produce that data and makes that available on the blockchain. So that's one aspect. The other one is that Pyth introduces this idea of a confidence interval. And a confidence interval is essentially a way to communicate how confident both the sources or the publishers feel about the prices that they're providing, and also how confident Pyth feels about the prices it's providing for the consumers, right? So I don't want to go into too much detail about how the confidence intervals work and how Pyth aggregates prices from different sources and makes that available. But our website, if you go to docs.pyth.network, there's a lot of information in there. And also you can go to the main website, pyth.network, and download the white paper, which also goes over these things, right? So so with that, next thing that I want to mention is, okay, so said that how Pyth works, how it makes this data available, etc. So let's look into how, in the context of Solana, as you know, like in Solana, you have these accounts, and accounts are a way to transmit state between transactions, right? So you do one transaction, it changes something in accounts, and then these accounts, they store data till the next transaction. So Pyth uses accounts to provide the Oracle data for consumers. And there are three different kinds of accounts that Pyth manages. So we have the first type, which is a mapping account. Second type is a product account, and then the third type is a price account. So let's go over them real quickly. A mapping account is essentially an index or a listing of the products that of the instruments that Pyth knows about, and it holds references to the instruments, and it also is implemented in the same way as a linked list. So if you're familiar with computer science data structures, you should know what a linked list is. So it's essentially a way to bypass a limitation that Solana had until very recently, in that an account has a fixed size. So in order for Pyth to grow the number of instruments that it offers, this mapping accounts were implemented as a linked list, so we could continue adding new products to the Oracle, right? Okay, so the mapping accounts, they hold references to instruments, and these references are actually referenced to the second type of account. So the second type is what we call the product account, and it pretty much just holds the metadata about an instrument. So for example, for company stock, it will show which country that stock trades, the symbols in different exchanges, and things like that. And that metadata, it varies depending on the type of instrument. So the metadata for equity is different than the metadata for cryptocurrencies, for example. And finally, there's this third type of account, which is called a price account. And the price account essentially holds the actual information that the consumers are interested in. So it will hold the price components, as we call it. So the price provided by each source, and also the aggregate price, which is what Pyth computes from the different sources and kinds of considers that the official price. And price accounts, they not only have the price, but they also have this value that represents the confidence interval that we talked about before. So let me share my screen, and we can look at the browser at the website, and we can see some of this information. So just give me a minute. I want to do a section of the screen. Right. So let me move this out of the way. Size that a little bit. Okay. So can you see a browser window on the Pyth website? Anyone?
Yes.
Yeah.
Yes.
Okay. All right. So I'm here at the Pyth documentation website. So as I said, we have this different types of accounts: mapping, price, and product. Here are some kind of examples of what they look like, what kind of information they hold. So you can go here to this Solana account structure page, and you see products. You see the price account. So you can see it here that the price is a number, confidence interval is also a number. So and also there's the exponent. So the way we store prices in the Pyth accounts is as an integer, and we have a separate field for an exponent, which pretty much tells you where you should put the decimal place. And then the confidence interval is represented by a single quantity. And the way to interpret that is, you look at the price. So say, for example, Bitcoin. So Bitcoin, last time I checked, was trading at around $29,000. And if you go to Bitcoin's price account, it will say something like $29,000 plus or minus, and then the confidence interval value, which for Bitcoin, it's probably like, I don't know, $50. So, 29,000 plus or minus $50. Another interesting thing that the price account holds is the status. So here you can check whether or not that particular instrument is trading, if it's halted, or if the status is unknown, or you don't know if the price is up to date, etc. And there's some other things like indicators, like moving averages and things like that. So yeah, so pretty much these are the types of accounts that we have in Pyth. And I wanted to mention two particular things about the Pyth account. So one of them is that, as I said, the mapping accounts are implemented as linked lists, and each mapping account in the linked list can hold over 600 different instruments. But as of today, we are, I think the number of instruments that Pyth knows about and provides data for is around 70 something instruments. And that means that we are still within the capacity of the first mapping account. So if you go out to like Solana Explorer and you want to take a look at the Pyth accounts, you'll notice that we only have one mapping account for now. And that's because it has a lot of capacity. So once we hit that limit, we'll create the second mapping account, and then we'll go from there. And then the second thing that I wanted to mention is that for each product, each instrument in Pyth has one price account and one product account. But the account structure was designed in a way that a product can have more than one price account. That hasn't happened yet. So all the products in Pyth, they only have one price account. But it's important to keep in mind that the design allows for more than one price account. Like, say, for example, say Pyth decides to support NFTs. And, with NFTs, you can have like the latest price for an NFT and also a different price account for like the floor price. So you can kind of like treat price accounts as kind of like value accounts. Most of the time, the only value that we provide is the price of an instrument, but there can be more than one price for a product. All right. So if you want to look into the actual implementation of the different account structures, I have an open tab here in my browser that points to the source code of the Oracle. So if you go here to on GitHub to PythNetwork and then Pyth-client, and you can go to the program directory and then source Oracle and then oracle.h. It's a header file in the C language. And if you have a little bit of understanding of the syntax, you can see what these accounts look like. So, for example, this PC map table structure. This is like the structure of the mapping account. PC prod is for products, and PC price info is a section of the price account information. So you can go in here, you see like this. So this PC price is the entire price account. So you can see like all the different attributes that it holds, what's the type for each one, and it's like a brief comment with a brief description of what it means. Okay, and the last thing that I wanted to show before we start working with some code is the Pyth website. So if you go to Pyth.network, you can go to price feeds, and you can see the actual data that's being published in real time. So here you have a table with the list of all the price feeds, and you can swap the network, so you can work in DevNet, testnet, mainnet, beta. The work we'll be doing will be mostly on DevNet, but if you're here on mainnet and you click on one of the instruments, so like say Apple USD right now has an unknown status, and here on the side you can see the current value and then the confidence interval. So Apple right now is priced as $148.40.5, with a confidence interval of plus or minus 11.5 cents. And if you click on the instrument, you get some more information about it. So you can see the actual price component. So these are the different sources that are providing data for the Apple price. And you can see the slots that they have published, their idea of price. So, each source, they do their own trades, or they produce their own data. So each one of them will say the price that they have, and also how confident they feel about these prices. So you see that there's some variation on the confidence intervals and also on the price. And finally, if you scroll down, there's also some useful information here. So first thing is the public key or the address for the product account and the price account. So if you're writing an on-chain application or program, or even if you're writing like a web application outside of the blockchain, these are the account addresses that you'll be using. So you can come here on the website and you can get the values from here. Also here on the left side, you get, so I mentioned the product account holds metadata. So you see the metadata here on the side. So you see some attributes such as the country, or like the symbol at the exchange where it trades. And then on the right side, you have the actual price information. So I mentioned the exponent. You get like the number of sources you have for this price, the minimum number of publishers in order for the aggregate to be computed, and then like status, some indicators, confidence, price, etc., things like that. So if you're interested in working with Pyth, it's the website has a lot of information. It's a really good reference material for development. Yeah. So with that, just want to mention what we're going to be doing next. So I thought it would be interesting to do two quick exercises. So first one, I wanted us to put together a web page that streams data from the Pyth Oracle and shows it on the web page. So the off-chain client, and then after that, we can take a look at using the Anchor framework to consume this data, so access the Pyth data from the blockchain, so from another on-chain program. So that's what we'll be doing. We'll be pretty much starting from scratch. I've already installed the tooling, the Solana CLI, Rust, the Anchor framework, etc. If you want to install them, you can just go to their websites, and they have instructions in there. But these two projects will be pretty much starting from scratch. Okay, so before we move on to the exercises, want to take a minute, ask if anyone has any questions, comments, or want me to elaborate on any of the things that I said. Now would be a good time. right. I guess we can continue. Okay, so let's do this. I have a terminal window here open behind my browser, and we're gonna work here. So I have an empty directory. So I'll be sharing all this code later today. Once we finish, I'll publish it on GitHub and make that available for you. But for us to start here, so the idea that I had for the off-chain client, so I want to use the Next.js framework to put together like a small React page, and then use the TypeScript Pyth client to show the prices in there. Okay, so I have another tab here in my browser with the Next.js quick start. So I'm just gonna like pretty much just copy some of these comments to get started. So we can do yarn, create next app TypeScript. So this is a command to create a new application. So do I need to pass in the name? Yeah, so let's just copy and paste that here. What's the project name? So the web page is pretty much going to be like a ticker for an instrument. So I'm just going to call it a ticker. I guess it will then install dependencies, create a new directory, create a project, etc. All right. So let's go into this directory ticker. And then we'll be running a command yarn dev, which is going to start a local server on my computer, and then I'll be able to access the application from my browser. So before I do that, I want to open a editor in this project. So I have here VS Code. Just move this a little bit to the side so I can go back and forth. All right, and then now I'm going to do yarn dev. So now there should be a server running on localhost 3000. So now if I open a browser window, localhost 3000, I should get like kind of like the welcome Next.js page. So that page is controlled from here, this index.tsx file. So what we'll be doing is we'll be removing most of this stuff. So I think I'm just going to copy it from this head part. I'm going to rename this to ticker, remove this metadata, there's no link. And then on the main content, I'll change the header name to Pyth ticker. And down here, I'll delete some of this stuff. And also this footer stuff, which I don't need. So I get like a very simple page. And then, okay, so Pyth ticker. So I'm going to do, so for the sake of the example, I'm only going to get one symbol to show on the screen and then get the price for it. So the one I'm going to pick is going to be the Sol USD pair. Okay, so let's add another header, Sol USD. And then finally add an H3 tag. And then here, we're going to be showing the actual price. So for now, I'm just going to put some question marks. I'll save this and go back here. So now you see that we have a page with just static data, right? So now we can actually start building the interesting part, right? So now I'm going to drop back to my terminal and I need to install some dependencies, right? So I'm going to do yarn add, and I need to add PythNetwork /client. So this is the Pyth client for JavaScript and TypeScript. And I'll just give it a minute, it will be installed. I may or may not need to also install the Solana Web3 JS client. I think it will be done for me automatically because it's a dependency for Pyth. Yes, it's here. So with that, I'm going to launch my server again, and then just refresh it to make sure it still works. All right, okay. So yeah, so let's go back to the editor and actually start writing some code. So first thing that I want to do is, for those not familiar with React, you know, the React has some mechanisms called hooks where you can maintain state, cause you know, side effects on the page. So for that, we'll be using the use effect and use state hooks from React. Oh. There's no space in here, and it's also not from, it's from. All right, and then here within the function that renders the page, I'm going to declare a sol price and set sol price variables using the state that starts at 0. And also I'm going to do sol confidence and set sol confidence for the confidence interval, also with the use state set to 0. All right. And then finally, I also added use effect. I'm going to use that in order to start the connection to Pyth, and you know, to start actually streaming the data. So this is mostly using the Solana bit. So this is going to connect to one of the RPC nodes, open a WebSocket, and you know, stream prices from there. So what we'll do is use effect, and then we declare a function. I only want this to run once when I open the page. So you're passing a second empty array argument to the use effect in order to do that. And then here from the inside, we'll do const connection equals new connection, and I'll pass in the RPC node URL. So we'll be working with DevNet because, you know, we're not doing any transactions here, but just DevNet, we can airdrop tokens and we can work without spending any money, and also without interfering with the real stuff. But the Pyth Oracle running on DevNet also publishes data that it's fairly accurate. It's not as accurate as mainnet, but it should work for this exercise. So I declare the connection variable, and also I need to pass in a program key. So the program key is the actual public key for the Pyth Oracle program. So how can I get that? If we go back to the website, I think it should be somewhere in here. Not 100% sure. Maybe it's on the documentation. Okay, yeah, I guess it's somewhere in the page. I'm not exactly sure where, but one way to get the address of the Pyth program, and for each network, you can do a DNS query for TXT record on the network, so DevNet, and then which program you want to get the address for. So in our case, it's just the Pyth program. We can also get the address of the mapping account, and we'll pass in v2, which is the current version of the Pyth Oracle .pyth.network, and that, oh, it's not DNS, it's dig, and that should return a TXT record with the public key for the Pyth program on DevNet. So if you replace DevNet here with testnet, it will give you a different address. So this is address for testnet, and also same thing for mainnet. But the one we care about now is DevNet. So I'll copy this address, and back here in my editor, I'll add in here inside this public key value, and we should be good to go. So now, like, I'm making references to this connection public key, which have not been imported yet. So let's do that now. I'm going to import connection and public key from Solana web3.js. That should resolve the error. And I think we can now go back to our web page and refresh it. Oh, I need to start the server again. All right. So I refreshed the page, still shows static content, but now we actually have the connection object and a program key here. So next thing that we want to do is we want to declare the actual Pyth connection. So this is just a generic Solana connection, and we want to use that to have a more like a Pyth specific version of the connection object. So what I'm going to do is I'm going to declare a Pyth connection, and then use the Pyth connection class and pass in my Solana connection object and also the program key. I need to go back up and declare this Pyth connection class, which comes from the PythNetwork client package. All right, so now we have Solana connection, we have the program key and the Pyth connection. So next thing we want to do is we want to declare a function that does something whenever we get a new price for the instrument that we care about. So in our case, it's SOL USD. So what we want to do is we want to call this Pyth connection on price change. And this will take a product and a price. And the implementation is whatever we want to do whenever we get a new price update for a product. So what we want to do here is we want to check if the product is the product that we care about. So in our case, the SOL USD instrument. And then if it is, we are going to use the hooks that we declared up here to update the values for price and confidence. And then finally, we're going to show the price and the confidence interval on the web page. So let's do that. So whenever there's a price update, what we want to do is we want to check if the product symbol equals crypto SOL USD, and this value, if we go back to our website and look at that instrument, you see that it's here on the product metadata. There's a symbol, and we want to check if this is the symbol that we're working with. So we want to check if the symbol is crypto SOL USD, and we want to check if there's a price for it, and we want to check if there's a confidence interval for it. If that's the case, then we set SOL price to price.price, and we set SOL confidence to price.confidence. All right, so we have declared what we want to do whenever there's a price update. Finally, there's only one missing piece, and that is we need to start the Pyth connection. So we have only declared everything up until this point, and now we add a Pyth connection dot start. So that should do it. It will fetch the data and store the data in the use state hook that we declared up there. So that's not enough to show it on the web page. What we need to do is we need to go back here and then use these values from the hook here. So I'm going to use curly braces and then sol price and sol confidence here. So we'll do sol price, and I want to do the little plus and minus symbol. I've checked before, and the HTML code for it is plus MN, and then I want to add the sol confidence value here. And if we save that, there should be no errors in the page. Cool. And then if we go back to the browser, it says failed to fetch. Okay, so that's not expected. Let's see why that is the case, why that's happening. I guess I forgot to say that the RPC endpoint is api.devnet.solana.com. Otherwise, it won't be able to connect to it. So now if we go back here to the website, yes. So now we see, you see that the price is changing. So it's being updated as new price updates for the Solana USD pair comes in. So that's essentially how you build kind of like here we're just doing the Sol USD pair, but if you want to put together like a dashboard with a bunch of symbols, kind of like you have on like trading terminals and things like that. So that's how you would do it. And essentially, if you go back to the Pyth website, to the homepage, and you'll notice that there's like a price feed widget here on the side showing some prices. So it's pretty much that's the same implementation. The only difference is that in our case, we're only doing the Sol USD instrument. So we can, this is mainnet, or if we switch to DevNet, give it a minute, you see that 402843, that should be the same thing we have here. All right, so that's essentially what we have for the off-chain part. Again, take another quick break and open for questions. Is it clear? Does it make sense? Any comments or questions about this?
Hello, sir. May I ask one question?
Hey, yes, of course.
Yes. I want to ask how to get the program key. I don't see how to get that key very clearly.
Okay. Yes. Yeah. So program key. So the way I got it. What I did is the Pyth administrators, they publish the program key and the mapping key as DNS records on the PythNetwork domain. So what I did is I used a DNS client to query the value for the DNS record that holds that information. So if you're on a Mac, you have this command line tool called dig. You should have it. It can also be easily installed on a Mac, on Linux. I'm not exactly sure if dig is available on Windows, but I know that on Linux and Mac, for sure, you should be able to get it. And the way you do is you do dig txt, because we want to get a txt record. And you pass in this subdomain that holds the information. So the one I used was devnet-program-v2.pyth.network. So if you do that, you get a response. And in here in this answer section, you see that here's the subdomain that I passed. And then this is the response. So you'll see program equals, and then the value for the program public key. In addition to the program, you can also get the mapping public key. So it's different address. And then finally, you can just switch the name of the network to get the same information for the other networks. Is that clear?
Yeah.
I know that not everyone is familiar with like DNS records and stuff. I will admit that this is the way I do it. There might be an easier way to do it. There might be like a web page somewhere in our documentation or even our website that has this information, but it's just like something that I may not be aware of. So I'm just doing like the way I usually do. But yeah, the information is out there, and you should be able to get it at least this way. Okay.
Okay. Thanks. It's clear for me.
Anything else on the dashboard part?
Hello, I have a question.
Yes.
Do you recommend we to hard code this key in our program, or should we inquiry from DNS in runtime?
Yeah. Yes. So that will be made more clear in the next exercise, because we're actually going to be using a specific price account instead of just like give me all updates and I'll filter on my side. So yes, you definitely want to copy the key and use it in your program, either on chain or off chain. So you don't need to be querying for this information every time you run it. Yes. These values for the public keys for both the mapping account and the program account are not expected to change, are not supposed to change. They're supposed to be stable. And if we plan on making changes, like if we plan on migrating the program account to a different address, that will be communicated with a lot of heads up. So, like probably take like weeks or months to make sure that everyone is aware of it and has enough time to migrate. But yes, you can consider these values as stable.
Good, thanks.
All right. I guess we can keep going. So next thing that I want to do is I want to use the Anchor framework, and I saw that on previous editions of the Solmeet workshops. If you guys have worked with the Anchor framework before, so we'll be using it to kind of like move a little faster on writing our on-chain program. So what I want to do next is I want to CD back into my Solmeet workshop directory, and now I will just run Anchor to show that I have it installed, and I'm using, I think I can do this to show the version. Yes, I'm using the latest version of the Anchor CLI, so 0.24.2. And what I'll be doing next is starting a new Anchor project. So last time I did that, I think it's using Anchor init, and I may need to pass a name. So, okay, so here's what I want to do for the on-chain part. This is going to be even simpler than the ticker exercise. So the ticker exercise actually, shows the price and confidence intervals on a web page. For the on-chain part, what I want to do is we want to write a little on-chain program that uses one of the Pyth price accounts and checks that the price status is trading, and if that's true, it's just writes 1 or 0 to another account. it's not very interesting. It's not very useful, but it should cover most of the work that you'll be doing to interact with the Oracle from an on-chain program. And then on your own, you can go and do more interesting things than just checking the status of a price account. So I'm going to call this exercise status. And if I type, if I run anchor init status, it should generate a new directory and install things in there. So I guess I can close my editor now. So this code that I've just written, I'll make that available later today for you, so you can use it as reference and then change it and make your own little exercise. All right, so let's now cd into the status directory. Okay, so now I have an anchor project in here. I'm gonna open my editor again, and this time I want to start by, so for those not familiar with the structure of an anchor project, you have a programs directory where you have the different on-chain programs that you want to build, and then you have a directory for each one of them, and then you have this task directory, which comes from with some pre-generated JavaScript code that you can use to interact with the program. So, just so we don't take a lot of time, we're not going to be building an interface to talk to this program. So we're going to be taking advantage of the test script to send transactions to the program. And then we can use like the Solana Explorer or the Solana CLI to verify that the transactions actually did what we wanted to do. Okay. So, yeah, so let's get started. So first thing I want to do is I'm going to go into my program directory, into the cargo.toml file, and I want to add in another dependency here. So if you go to GitHub, there is a project on the Pyth organization called github.com PythNetwork Pyth SDK RS. So this is the Rust stuff. The Rust libraries to interact with Pyth, and this is both on-chain and off-chain. So if you go Pyth SDK Solana, this is the parts that we'll be working with. There's some examples. There's even a test contract that you can play with, and on the README you also have some information on how to use it. So this is published to crates.io, which is kind of like the package registry for Rust packages. And if we go in there, we'll see that the latest version is this 0.4.1. So what we'll be doing is we'll be adding Pyth SDK Solana and then that version number. I actually did my like a trial of this exercise using 0.4.0. So let's use the latest one, and hopefully it will just work. So I saved this on the background. My editor will download and build this dependency, so we can now just move on to writing our program. All right, so before we actually start writing the code, I want to stop by another file. So there's an anchor.toml file, and this is kind of like a configuration file for how you interact with the program from the task script. And you see here that it's referring to localnet. It's using the localnet cluster, the localhost network in Solana. And we're not going to be using localhost because we want to interact with a real Pyth Oracle. So we're going to be replacing this to DevNet, just so we get actual data from Pyth. So we're also going to change it here. And this will be the address of the program, where it is deployed. I'm not going to change this yet because I need to wait. I need to build the program at least once. So Anchor will generate a key pair for it. And then I'll deploy it to Solana, and I'll have a public key. So I'll replace it here.
Can use Anchor keys list to generate the key first. Anchor keys list in terminal under this directory.
Command. Okay.
Anchor keys list.
Anchor keys
and
list.
Yeah.
All right. So this is.
You can see in the targets folder. And you have the key.
All right. Yeah. Okay. So yeah. Thank you. Thank you. What's your name?
Emerson.
Emerson. Thank you, Emerson. Yeah. That's exactly the information that I wanted. So yeah, I guess we can. Usually I would just wait for the first build and then copy it from there. But this is good. Thank you.
Yes.
Yeah. So let's replace it here. We'll also be changing it. The code. So we'll go to the source directory lib. Guess this is, we'll also replace it here. Yeah, so then now we can start working on our actual code. So, all right. So if we go back here to the web page for the Rust SDK, you see that there's like a little snippet of how to consume a price. So just gonna copy it, make it simpler. We'll use from Pyth SDK Solana, we'll be using this function, load price feed from account info, and also this price feed object. It's unused, so let's start implementing it. I'm going to change. So, in Anchor, you can declare different endpoints to call on your program, and by default, it comes with this initialize one. I'm going to change it to run because just for semantics, we're not going to be initializing anything. There's not going to be like multiple endpoints. It's just going to be one thing. So let's just call it run. Also change the name of the context struct for it. So just run here. All right, and next we need to define this thing. So let's go back here, run the derive accounts macro. It's where we define which accounts this endpoint instruction knows about and interacts with. So we'll start working with that. So first account that we'll be working with is the system program. Because the account where we're going to be holding the result of our transaction that interacts with Pyth, it's going to be created in the instruction to create this account will be included in the transaction. So we're going to be needing the system program because it's a requirement for initializing accounts and creating new accounts. So I forgot to add the life cycle annotation here. So just use info, which is what most places use. And then we'll do info and system for the system account. So the other account that we're going to be interacting with is this funding account. So this is the account they're going to be paying for the transaction that we generate. So just call it signer, life cycle annotation, just like before. And the next account, it's going to be the actual price account from Pyth that we're going to be using. So call it price. We're not going to be using the account struct from Anchor. We're going to be using unchecked account because the Pyth Oracle wasn't written with Anchor using the Anchor framework. And also it doesn't belong to this program that we're writing. So we just use unchecked account to keep it simple. Obviously, when you use unchecked account, you're skipping all the validations and checks that Anchor adds for you. So you want to make sure that you run a macro and then you do add constraints and eventually, if you want to write a program that interacts with Pyth and it runs in production or mainnet, you need to be a little bit more strict about how you use the price account. But for our exercise, this should do it. So add the lifecycle annotation. All right. So we have price. And then finally, we'll have this other account called output. So this is where we're going to save. So essentially what the program is going to be doing is going to access a price account in Pyth, check some information about the status, and then write a value to this other account called output. So output is going to be a normal anchor account struct, passing the lifecycle annotation and the output type for it. All right, so these are the accounts. Now I need to declare this output struct. So we'll do account macro, pub struct output. And here, essentially, what I want to do is just a Boolean flag. So it's just a byte that can be 1 or 0, and its name, it's going to be trading. So we're going to check if the status of the price is trading. If it is, we'll write 1. If it's not, we'll write it 0. And the type is just going to be an U8, so a single byte. All right. So now we have the structs that we need. We need to add some extra information to the list of accounts. So system account is fine. We can add an empty account macro here. For the funding one, we need account mut for mutable because this account is going to be signing the transaction and paying for the transaction fee. And the price account, we don't need anything. So it's not even an account struct. And then finally, the output account, we'll pass in some extra information. So in it, we want to initialize it because when we run it, it will not exist. The payer is going to be the funding account that we declared below. And we're only using 1 byte of space for this account. So on the space that attribute, we need to pass in 9. So the reason why I need to pass in 9 is because accounts created with Anchor, they need 8 bytes for this thing called a discriminator that Anchor uses to differentiate between among the different accounts in a program. So we're adding the 8 bytes for the Anchor stuff, and then an extra byte for our actual value here. Okay, so that should be enough. And we can now move on to the actual implementation of our instruction. So back up here to our run function, where we'll be adding so now we're going to go back to the browser and see the example of how we pull in the price feed. So there's a line here, we can pretty much just copy it. The line above, we're not going to be using because it's how you define the account info. We have already declared the price account here, so we can just use it from the context in the instruction. So I can go in here and paste my code. So let me close the sidebar to make it better. All right. So we're going to be loading the price feed from account info. And I'm going to be passing my price account from the context. So I'll do ctx.accounts.price. That should give me this price feed object with the actual information from the price account that I can query. Then I want to do a conditional on the price feed status and check if it's on a trading status. So I need to add another type here called price status that comes from the Pyth SDK Solana, and then we'll check if this value is equal to price status trading. If that's the case, we'll do CTX accounts, output trading equals true as you wait. Otherwise, CTX accounts output trading equals false as you wait. And that's about it. So that's all we're going to be doing in our program. I'm going to try to build this. It's going to fail for a reason that we'll see. So if I do anchor build, the reason why this is going to fail is I found out recently that now in Anchor, if you use an unchecked account, because you lose some of the safety features, you need to add a comment explicitly explaining why you're doing this and why it's okay. So while it's building, I'm just going to go ahead and add this comment. So I need to do like /check and just write something here. So I'll say that Pyth does not use Anchor. And save this. So now if you go back, this is, it actually built. I thought it would fail here. Oh, actually it says here, error, struct field price is unsafe, but it's not documented. Please add a, the thing we just added. So now if we try to build this again, all right, yeah, this time it worked. So let's, let me just go back to my config file real quickly. I think I have the right values. DevNet is my wallet. All right. Okay, so yeah, so now we do Solana program deploy, and we pass in the binary for program. It's not deploy, it's deploy. Let me see my Solana configuration. Yeah, it's pointed to DevNet. Looks good. Let's try it again. All right. This is not moving forward. Not sure exactly why. We'll leave it aside. Let's write our test. I'll actually leave this running. Maybe it will work eventually. But while this is running, let's go back and start working on our test case. So the test case is pretty much just going to be the client that we'll be using to interact with the program once it's on chain. So I'm going to go back here to my test directory and use this status.ts file here. So let's see, let's delete this comment. Have dependencies here. Yeah, okay. So now if we go back here, it's actually deploying. It was just like taking a little bit longer. So things I want to do here, just gonna rename this task from it does something to it runs. And I'm going to delete the contents of this, and then we can start writing an actual client for the program. So let's do this. So we have the program previously implemented here. Next thing we want to do is we want to have a wallet to pay for the transaction. So let's do const wallet equals anchor wallet local. So this will go into our configuration and look for a key pair to use as a wallet. So this is my local Solana key pair. I should have some balance in it. Yeah, I have almost 5 sol. And back here, okay, I have the program, I have wallet. Next thing is I need a key pair for my output account, right? So I'm actually going to create a key pair externally and read it from the file system here. So what I want to do is const output secret, and this is going to be equal to JSON parse, and I want to read a file called output.json to a string. So I'm using fs. I don't have it here, so I need to do import fs from fs for file system. Oops. Close this again. All right. So I have this output secret value, and now I need an actual output key pair. So we'll do anchor web3 key pair from secret key, and then I'll pass in my output secret. So there's just one thing from secret pair. It takes a uint8 array, and I think JSON parse will just produce a number array. So just to be sure, we'll do uint8 array from our value. Right. So now we have the wallet object, we have the output key pair, we have the program. Next thing we need is the actual public key for the price that we want to use. So let's go back to our price feed and then pick something. This time, let's do Cardano. So the ADA USD product will go in here, and then we'll see it's a bunch of components, people publishing its price. There's a product key, price key. So I want to copy the price key and then go back here to my program, and then we'll do price equals new anchor web3 public key, passing the public key for the price account for Cardano US dollars. All right. So I think I have everything. Now we can actually write the transaction and send it. So I go within the task block. I need to go here because this is what gets executed. So we'll do const tx equals await program methods, and then we'll do dot run. We'll pass in accounts, and the accounts will be price as price. Output, we'll pass in output public key because this is a key pair. For funding, we'll pass in the wallet public key. And finally, we'll pass in the system program. Program ID. All right. So we have our accounts, and next thing I want to do is tell who is going to be signing this transaction. So we'll call signers, and we'll pass in output because we're going to be changing the data, and we'll also be initializing the output account. So I need to pass in as a signer, and also the wallet. I need to pass in its key pair so we can pay for the transaction. We're actually not paying because this is all DevNet, and it's the sol is free. It's not real, but this is what's paying for it. And then we'll call RPC, which actually sends the transaction. So we chain a bunch of methods. So run is our instruction, the list of accounts, signers, and then we call RPC. If this goes well, I want to log the transaction. So let's just do transaction. That's it. So usually in Anchor, you use a test file like this one to, you run it on local net. So it will start a test validator, and you make a transaction, and then you check the output, the outcome of that transaction. You see if the accounts have the the right data, etc. And then you issue some assertions, and that's how you make sure that your program is doing what it's doing. In our case, we're mostly using the test script as like a handy tool to run our program. So that's why I changed the configuration to use DevNet. And I'm not doing any kind of assertion here. I'm just like issuing the transaction, and we're going to be verifying the outcome of this transaction using the Solana CLI. So we have our test, we have our program. So hopefully I have not made too many mistakes. Let's try to build the program again. We did not make any changes to it, so it's all good. Just deploy it again just to be sure. So it'll take a while. And then once that finishes, we'll call anchor test, and then we'll pass in a flag skip deployment because we've already deployed. I think actually like this comment that's running right now, it's not making any difference because we've just deployed a few minutes ago, but it's just wait to be sure. All right. So now we run anchor. There's one thing I forgot. So I'm reading this output.json key pair, which does not exist here. So let's create it first. So we'll do Solana keygen, new output would be output.json, no passphrase or anything. So now we actually have a key pair for this account that will be created when we issue the transaction. And I think if we copy it publicly and do Solana account, it should say that it doesn't exist. Yeah, account not found. So that's good. All right, so now let's run our test. Skip, deploy. All right, so we're getting an error. I've seen this before. It's not intuitive what's going on here, but apparently, in order to run tests in Anchor, they'll probably fix this soon. But you need to install a package that doesn't come installed automatically. Not exactly sure why. There's an issue on their GitHub repo, but I've seen this before. I've looked for the solution, and I know that I need to do yarn add ts mocha. In fact, even before I run it, I'll go here to my package.json and check if it's here. So yeah, you see that it's here. I think it has to do with a version number or something. So let me just run it. Yeah, so it updates to a newer version. So it's now on version 10 instead of 8. I think the version 8 that comes by default has some issues, and it causes the task not to run correctly. But yeah, just keep that in mind if you're following this exercise. So now let's go back and quit test, skip deploy, run it again. All right, seems like it's working. It shows an error down here, like program address not found. I think this has to do with the fact that we're using a test file to not run a test, but you see that the transaction that we logged is here, and we can actually copy this transaction and go into the Solana Explorer, switch to DevNet, and see it there. So you see it just happened a little bit ago. You see the accounts that we passed, all the information, see instruction data, etc. And the next thing that I want to do is go back here and do that Solana account command again. So now if I do this, I should actually get an account because, the instruction created the account when I pass in that init attribute to my micro. All right. So you see it here that this output.json now has an account in DevNet, And you can see that the data has 9 bytes of length, and that we have that 8 bytes of like the anchor stuff. And then we have this 1 byte here at the end with a value of 1. So it has a value of 1 because in our code, we checked if it was trading. If it was, we said true, otherwise false. And if we go back here to the Pyth website, and you'll see that the status is currently trading. Next thing that I could do is just, take a different price account. Take, for example, one that has a status of not trading and run, deploy the program again, run the test again, etc. And you would see that this byte here would not be 0.1, it would be 0.0. So it's not a very interesting exercise, but it should have made it clear how you can incorporate Pyth prices in your on-chain program. So I'll actually leave that as homework. So once I put this out there for you to use it, you can come back here on the price feeds and look for one that says unknown, for example. So this symbol here. There are a couple. I think there's more than one. There should be more than one. Yes. So Luna stuff. Some other stuff down here. So if you take one of these, you go in, copy the price account, and then replace it in the test file, which is here. So if you replace this value here, and then you regenerate the output key pair and run this again, you'll see that once you call Solana account on the output key pair, that the value will be 0. I won't do it because it will be boring. It will take a couple extra minutes, and we're already a little bit over time. And I want to leave some time for us to chat a little bit about these things, for you to ask questions, or if you have any comments, anything. But that's about it. That's all I had for today. I really appreciate everyone taking their times to listen to me, and I hope that I was able to convince you at least just a little bit that Pyth is pretty cool and you should definitely check it out. Thank you.